So, good evening and welcome to week 11 of the live interactive session of Neuroscience for Engineers. The course instructor for this course is Professor Vikas V from Mimans, Bangalore, and I am the PMR of Teaching Assistant Vikas Pandey from IIT Jodhpur. So, this is the brief about me. So, let's start with the summary. Okay. So, in the previous week, we talked about movement, right? We talked about before that we have talked about balance and how the we have even seen how the balance is used in conjunction with visual and audio feedback, audio input, right? So now in this week we had three lectures. First was the role of cerebellum in the movement. So cerebellum we all know is located on the like top of the head. That's the biggest part we can say. So there are two parts or two lobes, and there is a separation called vermis in the center. And there are surface convolutions called folia throughout the cerebellum. Okay. Then cerebral cortex and deep nuclei. So these input and output through peduncles. Uh, the structure of cortex is granular, and there are Purkinje and outer cortex layer. Fine. And whereas deep nuclei, that is located deep inside the cerebellum, that is dentated, emboliformic, fastigious, and globulous. Okay, so there are some functional division of the cerebellum. First one is the vestibular cerebellum, second is the spinocerebellum, and third is cerebrocerebellum. Okay, so the main role of cerebellum is posture, movement control, and coordination. Okay. And how this whole coordination of the movement occurs, that is, the input is through climbing fibers and mossy fibers. Then Purkinje cells have a role in modulation and inhibition of the movement uh, of these signals, and this also contribute into learning through synaptic plasticity and task mapping. Fine.
Yes, sir.
Okay. So
One more thing, sir. This vestibular, three things are there, no? Vestibular cerebellum, spinocerebellum.
and
Uh,
cerebrocerebellum.
what's their function? Any difference? Both are
Uh,
doing the same function.
no, they are functionally different. So vestibular, we have already learned the vestibular function. Like they are defined into three parts. Like one function can be the vestibular function. Second is the spinocerebellar, that is related to spine, like control through a spine. And then cerebrocerebellum, that is direct control by the cerebellum. Okay.
Okay, sir.
Then next is memory and learning. This is something that like most of us engineers are quite interested into how the not computer, sorry, how the brain learns and remembers, how memories are created, and that also in so less space. Whereas if we recount that how much visual, audio, and every memory is kept in our brain, if we try to put that much inside a hard disk or SSD, that will be a very enormous one, right? So this is something quite of interest of engineers. Okay? So memory and learning, they are complex processes closely related in neuroscience. So to understand memory and learning mechanism, we must understand the nervous system's fundamental properties. Right? That is why we have been learning a lot of things till now. Okay, this nervous system function is highly redundant and interconnected network. So this memory is mostly through networks, connected networks, and it is highly redundant, means repeatable in nature, or some part like not being used at all. Such structures are there. So the memory forms due to the interaction between sensory, motor, and processing system. Okay, so sensors are part of memory. Motor systems, like we have seen that muscle memory and these things we saw a bit, right? That there are cells which know how to respond. Even if we plan that we have to move this just this right hand, the other movement related to that is done automatically by the virtue of muscle memory. Okay. Now, next is the type of memory. So, memory is classified into implicit and explicit. Implicit means procedural, and explicit means declarative. Okay. Implicit memory involves unconscious uh, habit forming learning, while explicit memory are factual and event based recollection. Right. Uh, so, like how to eat food, how to drink, how to um, how to run, how to walk. These will be part of the implicit memory. Whereas you know someone, you remember some event, or you know someone's name, that is part of the explicit memory. Okay, so uh, this whole section is not, I can say that not fully understood yet, but yes, a lot of work has been done to understand how memory and learning works. So, as a, how this associative knowledge occurs. So, this was exemplified by Pavlovian conditioning, demonstrating the neural basis of memory formation. So, brain structure like hippocampus and amygdala play a crucial role in associative learning and memory. Associative means like when we are having a memory, we are associating it with some event uh, or some object, that thing. In this, there is an experiment where uh, they are keeping some dogs and giving them like some actions as well as some food is associated together. And so later on, what happens that even if that good or bad uh, action is not being done, the dogs will remember the food. Like saying the food, they will remember the action. So that is how the association is formed. Like good memory or bad memory, we can say, associated with our some objects. So these are associative learning. This not memory. This is the process of creating the memory. So learning is the way of creating a memory. Or and memory, we don't what we understand memory is some factual information only, but memory is also procedural in nature. That means how to do something. These things also are memory. Okay. So how this mechanism? What is the mechanism of learning? So we can say learning is encoding of information into memory. So we have, we are seeing, we are sensing things. We have our sense organs. We that include visual, auditory, olfactory, and this skin, everything. Okay. From this, we are getting some information, and that we are in a sense encoding into the memory. And this is facilitated by neural like synaptic plasticity and NMDA receptor. Okay. So this play a role in the mechanism of learning. So Procedural and declarative memory system work in tandem during learning tasks. So there is no difference that the procedural memory will be stored in a different way, and declarative memory, like factual things and procedures, will not be separated. They work in tandem during learning tasks. So uh, that itself shows how complex our memory processes are. Okay, so understanding memory and learning mechanism has broad implication for education, psychology, and neuroscience. So nowadays, you must have seen that there are proper ways that how you should teach your kids so that they develop uh, good skills, their memory will increase, and these things. So that also is an advantage. If we know the fundamental how this mechanism works, we will be able to improve our learning, education, as well as we can understand different psychological reactions, and we can avoid some things, some psychological problems, as well as some improvements can be done using understanding this. So that this insights can inform teaching strategy and therapeutical intervention for memory related disorder. Then second and very important role is of NMDA receptor. Uh, in fact, the last lecture was quite much dedicated to NMDA. So, what is NMDA? NMDA is a chemical name, and methyl D aspartate, that is a receptor, or glutamate. So, it will bind with glutamate. That is the primary excitatory neurotransmitter in human brain, and this plays a very important role in memory. They are stimulated by glutamate, allowing calcium influx. We have earlier also seen calcium influx also plays a role in case of muscle movement, right? Am I right?
Yes, sir. Yes, sir.
Yeah. So then removal of this calcium block increases the calcium of magnesium block increases the calcium influx, affecting the cellular processes. Then one term which I was saying again and again in the previous slide, that was synaptic plasticity. Plasticity, as we know, is flexibility, and synapses. We have been learning about synapses from the first week only. Okay, so what is synaptic plasticity? This is This synapses change in response to a repeated stimulation. So we have learned about action potential, right? There was an action potential. No, yes, sir. Like there was an action potential, complete action potential, right? So and the action potential was due to uh, stimulus. Now it is saying that if we have a repeated stimulation, okay, the synapses changes. That means the synaptic connects will change according to different stimulus. So something is being repeated again and again. So these connections will change, and that will be faster accessible. We can say, okay, and increased stimuli leads to strengthening of synapses. So the connection will become strong if there is a higher number of this stimuli, enhancing the probability of action potential generation. That is why it is said that like if we are learning something repeatedly, that will make the synapses strong. Uh, like the bonding, the structure will be becoming more strong, and that is why that part will be quickly accessible in our memory, and this is due to the synaptic plasticity. Then how the memory is formed? We know NMDA receptor is there. Our synapses has synaptic plasticity. Then how is the memory formation taking place? The memory formation involves multiple layers, including molecular, synaptic, and network pathways. So it is not just stored in one specific place. It is by the virtue of molecular, synaptic, and network pathway. They are quite dynamic process involving changes or modulation in synaptic strength and the number of synapses. So, in a sense, we are training our neurons to uh, act or behave or have such connections based on learning, and that forms the memory. So memory is nothing but we can say the specific orientation of molecules, synapses, and the pathway how these action potentials will travel. That actually itself is a memory. Okay. Then comes habituation, sensitization, and memory. So habituation involves a decreased response to repeated stimuli. That means if sometimes it happens that something becomes uh, so much part of our work or so normal that we don't need to put it in memory. It is there, like uh, something is happening again, again, and again. So over a period of time, the strength now is that when some stimuli is occurring again and again, the stimulus, the response actually is decreasing. This is called habituation. Okay, while there is something called a sensitization, which involves increased response to noxious, like that is less less number of stimuli. So this is something different than our memory formation. So memory process extends from synaptic mechanism to psychological and behavioral response. So we can say, in fact, we just know an overview how this is working. If we try to go very deep into it, like it is not still well understood, I will say, uh, not so well understood that we can directly replicate it into something like our computers and machines yet. But some way we are able to understand that it is intervening into it is due to this NMDA receptors and synaptic plasticity that play a role. But yes, this part we have understood that learning is the way of creating memory, and that is why you must have seen that nowadays, like there, there is something like machine learning. I think you are working on machine learning, right? Supervised, unsupervised learning,
Yes,
and
sir. Yes,
everything.
sir.
Yeah. So we have understood this part that learning is the way of creating, like making big that information into small parameters, but understanding the replicating the whole neural structure of memory and learning, that is still a bit like still a work in progress, right? So any questions still here?
No, sir. When we see the questions, we will discuss.
Yeah. So you are back home or still in Kerala?
No, sir. We back here in Vizag. Only few days I got.
So let's start with problem. What is the central part of cerebellum called? Vermis, folia, lobes, or peduncles?
Varmis, sir.
Vermis, because that is the separation which connects the two lobes. Which cells are primary cells in cerebellum? Granule cell, deep nuclei, Purkinje cells, or clumping fibers?
I think Purkinje cells, no?
Purkinje cells, yes. Purkinje cells, these are the primary cells in cerebellum. They are characterized by large size and multitudes of branches. They have a lot of branches, and this forms the major part of the cerebellum. The cerebellum outputs through climbing fiber, mossy fibers, deep nuclei, or granular cells.
It is through deep nuclei, no, sir. And
Yeah.
it's,
The output of the cerebellum is through the deep nuclei, which receives inhibitory input from the Purkinje cells. So, Purkinje cells are part of the cerebellum. They are sending the inhibitory input to the deep nuclei, through the deep nuclei going forward. Which fibers comes from inferior olivary nucleus? Climbing fiber, mossy fiber, granular fiber, or parallel fibers?
This olivary nucleus, uh, it is mono, sir, only one that is climbing, and mossy fibers are many to one.
Nine. No. So
But
this is climbing
climbing,
fibers, right? So they originate from the inferior olivary nucleus and they synapse towards the Purkinje cells, providing excitatory input. So excitatory input from inferior olivary nucleus through climbing fibers to the Purkinje cells, and then the Purkinje cell gives the inhibitory uh, output to the deep nuclei. Fine. How does the cerebellum contribute to learning? By modulating neurotransmitter release, by directly controlling muscle movement, by regulating sensory input, by inhibiting deep nuclei activity.
it would be inhibiting deep nuclear activity.
It is
Mm,
by
okay. I have a doubt, sir, because it's averaging out the signal. So
it,
modulation may be the correct.
yeah. So it is uh, the cerebellum learns by modulating neurotransmitter release in response to repeated tasks, leading in change in synaptic stream. That is synaptic plasticity. So, what is the role of Purkinje cell in cerebral circuitry? So, we talked about the circuitry, how this works. So, it provides excitatory input to deep nuclei to receive input from climbing fiber and mossy fibers, to modulate the activity of climbing fiber, to regulate granular cell activity.
I think it is B, sir, to receive input from climbing fibers and mossy fibers.
Moss. And does it not provide any input to deep nuclei?
Actually, reverse. It is coming from. Okay. Sir, I don't know, sir. That first one also is
No,
input.
no. This is right. The answer is right, but it
This also
provides
partially right.
inhibitory.
That is
It does not,
inhibitory, yes.
yeah, it is inhibitory in nature, not excitatory
Not
in nature.
excitatory, yes.
Yeah. So that word has only been changed. So they receive input from the climbing and mossy fiber and provide inhibitory output to deep nuclei, thereby regulating the cerebral activity. What is the fundamental property of nervous system highlighted in the lecture? Is it uh, linear organization, redundancy and overlap, singular pathway function, or fixed endpoint structure?
Redundancy and overlap.
Overlap. So this is the way that makes our actually the memory and learning quite fascinating, right? We have like in case of our computer systems and memory, we are fighting a lot of removing redundancy, right? But in case of brain, it is based on redundancy and overlap. That makes it quite unique. So this nervous system function as a network with redundancy and overlap among pathways. So that is why it is a bit complex, quite complex to understand. Which classification of memory involves unconscious habit forming learning? Is it explicit memory, semantic memory, procedural memory, or declarative memory?
It is a part of implicit memory, sir. So it must be procedural memory.
Procedural or implicit memory. Okay. Just not able to write this, right? So this involves unconscious learning through repetitive and habit forming. So this is implicit memory, and explicit memory will be declarative info, right? So, what is the term used for encoding memory in biology? Is it processing, encoding, storing, or learning?
Encoding memory. That is learning, sir.
Yes. Through learning, we are encoding the memory. Okay. So, we can say that learning is the process or the method by which memory forms. Okay. Any memory is through learning. Learning does not only mean learning through books or this, it also involves experiences and everything, right? Which experiment discussed in the lecture demonstrate classical conditioning? Penfield's motor
Um,
cortex mapping? Yes.
Pavlov's dog experiments.
Pavlov's dog's experiment. And what was done in this experiment? Do you remember?
Actually, they give food. After that, just put a ring a bell, then give food. Then saliva formation is there. So without food, only bells also saliva formation will
Saliva
come on the
formation.
dog.
Yes.
So it is because of associated memory. This
Memory.
MBA people will study in the organization behavior this experiment.
Yes, this experiment. And there is one more experiment. I don't know, like, what is its significance exactly. Like, there is something that they are keeping some monkeys in a cage, and they are giving some food. But whenever this, whenever they come to touch the food, water is thrown over them. So now one by one the monkeys are replaced and all, but
Yeah,
still they have this habit that they will not if if someone goes to touch that food, they will beat all the monkeys will beat that monkey that don't touch it,
yeah,
even
yeah,
though
yeah.
there is no
Got it.
water. And so this is something to study memory and experience based memory and habit forming. Like they have a habit, and that is in fact that is from coming from someone else, that you don't have to touch something. Like there are a lot of such experiments being done. Okay. So demonstrate classical conditioning, uh, associating a neutral stimulus, that is sound, with a natural response, that is salivation, through repetitive pairing with food. So this might happen with everyone. Like I used to have that whenever I will recall a memory, like when I first went to my school hostel. Uh, Whenever that memory comes to my mind, a the smell of that hostel, or this that was a new formed hostel, that smell I can remember. So somehow that smell has got associated with that memory. So some association occurs. Although I think that smell is has no role in the hostel or something, right? But whenever I remember that, that smell I can remember. So something like this, it's through what we can say pairing. Like we are learning through pairing experiences. So, which brain structures are primarily associated with declarative memory? That is the explicit memory. Hippocampus and amygdala, cerebellum and brainstem, frontal cortex and parietal lobe, occipital cortex and temporal lobe.
Hippocampus and amygdala. Amygdala.
Amygdala. So, declarative memory involves facts and events. Is primarily associated with brain structures like hippocampus and amygdala. What is the significance of phasing and timing in associative learning? It ensures unconscious learning. It minimizes declarative memory uses. It facilitates procedural memory formation. It enhances explicit memory consolidation.
Sir, I don't know. I don't understand, sir. What is actually facing and timing?
Uh, when we are talking about associative learning, no, they like there are a process like phase and time. Phase we know like some difference, right? So these are associated with facilitating procedural memory formation. So, like if you see the lecture, sir has spent a lot of time explaining this part, that how the procedural memory forms uh, due to phasing and timing. Like we can say something like repetitive in nature. Like you are doing something after a time. Suppose that there is something like you have the habit of like you are making tea and you are stirring it 4 or 5 times. You have learned it like this. You have to stir it for 10 times, and then you have to put some ingredient. Okay. Later on, what happens that there is some association that you are not counting later on, but automatically you will stir it for 10 times and your hand will go like to take the ingredient. This happens, right? Are you getting my point, or should I? Uh,
Sir, I couldn't get your point, sir.
okay, okay.
Phasing
So
and timing means it is repeated action only. Or
yeah, repeated action, and that also like what I will say. Let me take some other example. Uh, okay, like in case of when we are operating some machinery, right?
driving will have
Driving,
taken
yeah,
example.
driving will be better, right? So automatically, like we know that a turn is like suppose that you are practicing on the same road many a time. So at a place or at a time, automatically your hand goes towards the uh, gear to change the gear, right? If you are on a manual system. So this is something that has developed over a period of time, that before turning you are changing the lowering the gear, right? So that automatically will come like that automatically will be in your memory. You might not be doing it purposefully. You are not very mindful about it, that now I have to change the gear, when you have learned over a period of time, like you are driving from for 10 years, something like that. So you don't need to remember, okay, now I have to change the gear. When you might have started learning the driving, you must be conscious and changing the gears and all. Later on it comes automatically, right? So such things are based on repetitive phasing and timing, and that is how associated. Like automatically the speed goes up, your hand goes towards the gears to change it. That is something you are doing, though you are doing not fully unconsciously, but that is there is a memory associated. You don't have to put a lot of calculation and all to do that, which you might be doing at the beginning of your driving and all. Is it a bit relatable now? Hello.
Yes, sir. Yes, sir. I got
Yeah,
it, sir.
got it. Which receptor molecule is discussed as essential for associative learning? NMDA receptor, GABA receptor, serotonin receptor, or dopamine receptor?
It is NMDA receptor, sir.
The- So the lecture introduces NMDA receptor as the significant molecule associated in learning process, and it has very important role in memory formation also. So, what is the primary neurotransmitter responsible for stimulating NMDA receptor? Dopamine, glutamate, serotonin, or acetylcholine,
Glutamate, sir.
glutamate. So, NMDA receptor is uh, stimulated by uh, glutamate. Which ions flows into the cell when NMDA receptor are activated? Sodium, potassium, calcium, or chloride?
That is calcium, sir.
Calcium. So activation of NMDA receptor allows calcium to flow into the cell. What happens when the magnesium block is removed from NMDA receptor? Glutamate is released, sodium influx increases, calcium influx increases, or potassium efflux decreases.
Actually, sodium influx increases or calcium influxes increase.
B or C, right? So it
Uh,
is C, that is, removing the magnesium block increases the calcium influx into the cell. So which neurotransmitter is associated with habituation? Glutamate, GABA, dopamine, or serotonin?
Same thing only, na sir? Glutamate only, na?
Neurotransmitter is associated with habituation. Glutamate uh, act, activates NMDA, right?
NMDA.
Yeah.
GABA, I don't know.
Uh, it is
GABA.
GABA. Habituation, the reduction in response to non-aggressive stimuli is associated with neurotransmitter GABA. GABA, its full form is gamma aminobutyric acid. These are chemical compounds only. So we can say that what was being said, you have seen that Munna Bhai MBBS or something like Lage Raho Munna Bhai, I think. You have seen that movie, right?
Sir, I'm
No.
not watching any
Okay.
movies for last
Okay.
20 years.
Okay, okay. No, that's a old movie. So there also, like he says that there is some chemical problem in my brain. So actually, whenever we say like our memory, everything is actually chemical based, right? So there is actually, if you are having some brain issue, it can be seen that there is some chemical imbalance in the brain, right? So, what is the opposite of habituation? Is it sensitization, desensitization, adaptation, or conditioning? We have three things, right? Habituation, memory, and one more. So, what is that?
This conditioning, desensitization. I don't know, sir.
It is the
Uh,
sensitization. That in case of habituation, there is an like something over a period of time being repeated again and again. The response towards that stimuli will decrease. In case of
decrease.
in case of sensitization, uh, there is small response like and
Yeah.
the sensitive there will be response that is uh, opposite of the
That means the amplification of the signal.
yes amplification
Other,
of the sense. So sensitization and habituation, they are opposite of each other. Which brain structure is responsible for emotional responses? Amygdala, hippocampus, thalamus, or hypothalamus?
what is amygdala?
Amygdala.
First
This
one.
is responsible for emotional
Emotion.
response. What processes involves the closure of potassium channel to maintain depolarization? This is something that we have been discussing from the first class itself, right?
First class. First
Yeah.
class.
So, uh, is it habituation, sensitization, long-term potentiation, or classical conditioning?
But I don't know, sir, the answer. It is a classical conditioning, long time.
It is long-term potentiation that involves closing potassium channel to maintain depolarization and enhancing synaptic activities. Okay, so this much questions only for today. Uh, any other
Sir,
question? Yeah,
these all questions, if it is in a PDF form,
I have
can we
already
give to us
given it. I think
in the?
uh, yeah. If you go to the course,
Mm,
there is a section live interactive session. Okay, if you click on that, an
okay.
Excel sheet will open. In that, all the slides are there. All the slides I have uploaded, both annotated and unannotated. Till week 10, you will find. Today, I will be uploading the week 11 also.
In that links are there. Wait, another one
Yeah.
I will see.
First one,
Where it is?
first one is the video links. Second one, one single link is there. That
Oh,
is the drive link. There all the lectures, all the PDFs are there.
no, sir, I'm not getting that.
Okay.
Problem solving session
Yeah, yeah.
is there.
Yeah, problem solving session is there.
In that, first one is recordings.
Hmm.
Another is survey. Transcript.
No, no.
Another,
Uh, Let me check.
it is not there.
Okay, let me check. No, I think this is the this one. Live sessions. Okay, this is I am opening the old one. Hmm.
Okay, presentation folder link. Okay,
Yeah,
it is there.
presentation folder link. Yeah, some. If you
Yes.
open that, you will find.
Okay, okay. Sir,
Are you able
this
to?
one is enough, no, sir? We will.
Yes, most probably. And I think we have covered most of the part. Like we are not skipping anything, right? So I think this much will be enough. And these are questions like I have prepared on my own. Like this is not the questions given by sir. They are a bit different than what is given for you people, right? So this these are something that I have made to cover almost all the parts of the lecture. Okay, so I think that will be fine.
This one you only prepared now. So
Yeah,
you only setting the question paper? No.
no, no, that will be set up by sir.
Oh, surprise.
Surprise. Yeah. Yeah. Sir might have posted in the discussion forum like question pattern or something, and I'm not sure how many people have registered for the exam. Uh, I think you have registered, right?
Yes, sir, yes, sir.
So
But
I'm
I
not.
didn't get any this one.
Uh, Now,
Uh, that is whole ticket and all they're supposed to send.
okay.
It
Yeah,
is in
that.
next 24th, no, sir?
Yeah. So I think that
Uh,
will be done once we complete the course. That's why it is pending, maybe.
uh-huh.
Like the last week is still pending, right? 1 week is there. So next week we will be completing that. Uh,
Uh,
yeah.
so you
In
will
the
be
mean,
uploading both 11 and 12 lectures
yes, yes.
totally.
Yeah. Today 11th will be uploaded, and once we complete the 12th lecture, we will be. I will be uploading that also.
Because if possible, can you combine everything and give a single thing will be easy.
Okay, not an issue. I can do that.
Mm.
In the
And
last,
this,
I'll combine into one
mm,
PDF, and I will be.
no, no, if possible, sir,
Hmm.
I want to take a printout. So all question, one slide is one, I
Yeah, yeah,
mean one question.
yeah.
It
One
is in a
slide is one.
slide.
Uh,
Mm. If it is possible,
what you can do is
I
that while.
have to get test the copy and put it in a normal paper. I mean, one sheet it has some 10 20 questions. I can take only some 10 printout or
Yeah.
now enormous
So
printout we have to take.
yeah, what you can do is that while printing, you can put like 6 or 8 slides in
Yeah,
one
yeah,
page. That
like
that
that.
will work, I
Okay,
think.
okay, okay,
Yeah,
okay.
that you can do. That will reduce your number of pages, and it will make like
Mm.
small handout kind
But
of.
if you have some Word format or normal PDF thing, including
Okay,
entire
no,
questions,
yeah,
so
I
then
have
it
not
was
made anything like that.
like that.
Like,
Okay,
yeah, I have made like this only because directly I'm making the questions here on
okay, okay, sir.
separately.
So I
Yeah,
think I attended almost all
yeah,
video lectures.
attended all. Yeah,
So I think that is enough for exam, or you
yeah,
have to prepare.
you just. I think you just go through.
That book I took a printout. One last one transcript book is there.
Yeah,
Means
so that is the whole
that
lecture. Yeah,
all lectures. That I
yeah,
took printout and
yeah,
three books. Then I think I'll take all these assignments, 10 questions printout.
yeah.
That will be enough, no, sir?
That will be enough, most probably. Yeah,
But
you have to
neuroscience ka 7 volume also I took printout. That is big
big book.
books.
Yeah.
That
Best
itself
is
around 10 kg.
yeah. If you are making notes while s- li- uh,
Mm.
hearing the lectures, that will be the best thing, because personal notes are the best one, because
Yeah, yeah, true.
as per my experience, like whatever study material you get, but if you are making your own notes while
Yeah.
attending the class or something, that is the best thing that helps.
Then I have to, I didn't do that, sir,
Yeah, because
because of
in
some laziness. I didn't do
yeah,
that. Somehow I have to complete the class. I didn't take any notes.
yeah, not an
Many
issue.
of the
Like
things are not available. Means I couldn't understand. After that, I see some animations. What is cerebellum?
yeah,
Some animation videos are there.
yeah, I should have
Because
put
I'm
some.
not from bio background, so
Yeah,
initially couldn't.
yeah, some images should have been put, but like most of the images, like we cannot put any copyrighted image and a lot
Yeah,
of
yeah,
things.
no, 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 no problem, sir. It is
Yeah,
available in net.
yeah, it is
You will
available in that.
see cerebellum also.
Yeah, yeah.
Oh,
Okay, so
okay,
that's
sir.
all for
Thank
today.
you.
See you in the next
Okay.
class.
But
Bye.
next class on Thursday, you are saying?
Uh,
Or
Next class is on Tuesday, and one class after that, next Tuesday and Thursday, we have a class. This week,
okay,
no other class. Next Tuesday, we will
okay.
have a regular class, and then on Thursday, we have an extra class, which we can cover some parts. You can say in advance that what topics we can cover. Uh, if you want some kind revision kind of thing, so we can
Yeah, yeah,
discuss. Yeah.
yeah. Yes, sir. Then. Okay, okay. Thank
Thank
you.
you.